All right, so today we're going to dive into something pretty wild.
Oh, yeah.
Quantum computers. Have you ever heard of those?
I have.
Yeah, they're like computers, but like way, way, way more powerful. Like they could do things normal computers can only dream of. We're going to be talking about one specifically today. It's made by Microsoft,
Okay.
and it's called the Majorana 1 chip. And by the time we're done here, you'll be able to like explain it to anyone, even like a 5-year-old,
Okay.
ready to get your mind blown.
Absolutely. It's fascinating, even if you work with them all the time. Let's just say that.
So first things first, like what even is a quantum computer?
Well, imagine you've got like a computer that's really good at solving puzzles.
Okay, I'm imagining a computer wearing a detective hat.
Okay. Well, picture this then. Is playing with a light switch. It can be on or off, right?
Mm-hmm.
Well, this special computer can make the light be both on and off at the same time.
Whoa.
That's the magic of quantum computers. They can be in multiple states, like at once. And that lets them solve puzzles much faster than, like, your normal computer.
So it's like they have superpowers or something.
That's a good way to put it.
Okay, so how does Microsoft's Majorana 1 chip fit into all of this?
Well, that's where things get really interesting. Microsoft has built their chip using something called a topoconductor. Now, to understand this, imagine you're braiding hair,
Okay.
okay? Each strand of hair is like a tiny particle, and that particle is called a Majorana particle.
Okay.
Now, these particles are special because they are their own mirror image.
Oh, wow.
It's like looking in the mirror and seeing yourself, but it's also your opposite at the same time.
Okay, that's a little mind-bending.
Oh, it is!
I'm starting to get the picture, though. So these Majorana particles, which are their own opposite, are braided together in this topoconductor thing.
Yes.
Then what?
Well, by braiding these particles together in different ways, Microsoft can actually store information and do calculations.
So it's like using the braids to write a secret code or something.
Yeah, that's a great analogy. And the really cool thing about it is because these particles are so stable, the information is a lot less likely to get messed up.
So it's like having a really neat and tidy braid that doesn't get tangled easily.
Exactly.
Makes sense. So this topoconductor thing is like the playground for these special particles to like do their magic.
Right. It is, and it's a brand new state of matter. It's not a solid or a liquid or a gas. It's something completely different.
What?
Yeah.
So they discovered a new state of matter?
It's a theoretical state of matter.
Okay.
That still pretty awesome, and they're using it to build these super stable qubits.
Wait, qubits, what are those?
Think of qubits like a building blocks of information in a quantum computer. So they're like the ones and O's in a regular computer.
Okay.
But way cooler.
So Microsoft has basically figured out how to build like a really reliable quantum computer using these special particles and like this new theoretical state of matter.
Yeah.
That's amazing. How do they even like create this topoconductor thing in the first place? What's it even made of?
They combined two different materials, indium arsenide and aluminum. And they did this at extremely low temperatures.
Like how low?
Almost as cold as outer space.
Oh, wow.
It's like mixing ingredients for a special recipe, but instead of a cake, you get a topoconductor.
Cool.
Yeah.
Okay, so we've got these super stable qubits made from these Majorana particles all hanging out in this like amazing topoconductor playground.
Yeah.
What happens next? What can we actually do with this super powerful computer?
Oh, that's a fantastic question. That's what we'll explore next time.
Oh, can't wait.
Yeah. So before we went to our little break, we were talking about how Microsoft is using those special particles, the Majorana particles, and a new state of matter, that topoconductor thing, to build a super powerful computer.
Yeah, it's like they're creating a whole new world inside that tiny chip. But I'm still a little fuzzy on like what this supercomputer can actually do. What kind of cool things can it help us with?
Well, imagine if you had like a really, really tough puzzle.
Okay.
And it would take you like years and years and years to solve.
Okay, yeah.
This computer could solve it in like a few seconds.
Really?
Yeah.
So it's like having a super brain that can solve anything.
Yeah, that's one way to put it. So for example, it could help doctors discover new medicines like way faster.
Oh, okay.
Because right now it takes a long time to figure out how all these different chemicals work together to, make people feel better.
So this computer could be like a superhero, helping us fight off sickness.
Exactly. It could also help us create new materials that are stronger and lighter. Like imagine cars that are super safe and use very little fuel.
That would be awesome.
Yeah.
I bet it could even help us understand the universe better, like how stars are born or what black holes are made of.
You're right. It could even help us find solutions to like climate change by figuring out how to use energy more efficiently.
So it's like a magical tool that can help us solve all sorts of problems.
Pretty much.
Okay. You mentioned earlier that some scientists are still a little unsure about Microsoft's claims, though. Like, what are they worried about?
Well, some scientists think that we need to do some more experiments
Hmm.
to be absolutely sure that these Majorana particles are actually doing what Microsoft says they are.
So it's like double-checking the magic to make sure it's real magic.
Exactly. And even if everything checks out, it'll still take some time before we can use these computers to do all those like amazing things we've been talking about.
Oh, so it's not like we'll have these supercomputers in our homes tomorrow.
Not quite.
Okay.
Building these computers is really hard, and they need to be kept at extremely low temperatures. I'm talking like almost as cold as outer space.
Hmm.
Yeah.
So we'll need to wait a little while for these computers to warm up to us.
Yeah, I guess you could say that.
But it sounds like it'll be worth the wait.
I agree. The possibilities are really exciting, and it's just incredible to think how far we've come. Remember, we started by talking about like simple things like light switches and braiding hair, and now we're discussing computers that could like change the world.
I know, right? It's like a science fiction story come to life. But before we get too carried away with all the possibilities, maybe we should like take a step back and see how Microsoft's approach compares to, what other companies are doing in the world of quantum computers.
That's a great idea. Let's dive into that next.
We've been having so much fun learning about Microsoft's quantum computer. It's super cool.
It's definitely been a journey. We talked about special particles, braiding, and even remember that new state of matter, like a magic playground for those particles.
It's like a whole new universe inside that chip. But before we wrap up, I've been wondering, are other companies trying to build these supercomputers too?
Oh yeah, definitely. It's like a friendly competition to see who can create the best quantum computer.
Oh, so it's like a race.
Kind of, but everyone's also working together. Scientists are sharing ideas and helping each other learn. It's a real team effort.
That's awesome. So how are the other companies building their quantum computers? Are they using the same ingredients as Microsoft?
Some are using different ingredients, but the goal is the same, to build a computer that can do amazing things.
Okay, so it's like different recipes for the same delicious cake. What are some of those other ingredients?
One of the most popular is a superconducting qubit. Imagine a tiny wire that can carry electricity perfectly, no bumps or obstacles. It's like a superhighway for electricity.
Whoa, a superhighway for electricity. So these superconducting qubits are like tiny roads inside the computer.
That's a great way to think about it. These roads help the computer store information and make calculations, just like those braided Majorana particles in Microsoft Computer.
So it sounds like there are lots of different ways to build a quantum computer. But which way is the best?
That's a really tough question. Each ingredient has strengths and weaknesses. Some are easier to work with, while others are more stable and make fewer errors.
So it's like choosing the right tool for the job.
Exactly. And sometimes the best solution is to combine different ingredients and get the best of both worlds, like mixing and matching to create the ultimate quantum computer.
That's so cool. So even though we don't know what the future holds for quantum computers, it seems like there are so many exciting possibilities.
Absolutely. We're still in the early stages of this journey, but it's clear that these computers have the potential to change the world in ways we can't even imagine.
I can't wait to see what they come up with next.
Me too. It's like watching a science fiction movie, but it's real.
Well, this has been an incredible deep dive. Thanks for taking us through the world of quantum computers.
My pleasure. And remember to keep asking questions and explore the world around you. You never know what amazing discoveries you might make.
That's great advice. Thanks for joining us on the deep dive, and we'll see you next time for another fascinating exploration.